All right, we're going to look at section 6.3, areas under any normal curve. So in the last couple sections, we've been talking about normal distributions and the standard normal curve. And now we're going to look at converting any normal curve into the standard normal curve. That's the goal here for this section. And then we'll talk about some ways of looking at data and determining, does it look like it comes from a normal distribution? So just let's see. Okay, so just a reminder, standard normal distribution, the mean is at 0 and it has a standard deviation of 1. And so it looks like this. And what we're going to do is we're going to say, okay, well, 1 unit is a standard deviation. The second unit, you're at 2 standard deviation. You're at 3 standard deviations. So we're going to say, oh, that's just like the z values. We calculated z values, and those are just the number of standard deviations you're at. And so, reminder of how you calculate those for any normal distribution. Those z values, you take your value, your raw score, minus the mean to figure out how far away from the mean are you. If it's negative, you're below the mean. If it's positive, you're above the mean. And then you just, how many standard deviations is that? So you divide it by how big a standard deviation is, and that'll tell you the number. And again, it doesn't have to be a whole number. It can be a decimal, or a portion of a standard deviation, or 1.87 standard deviations or something like that. So we're going to be converting our normal distributions using their z-scores into standard normal distributions. And then what that means is we get to use those charts that we have in the front of the book. So let's say we have this. Find the probability distribution of this. And we want to go, okay, I want to get a value between 10 and 26. I know the mean is 15 and the standard deviation is 4. So what I'm going to do is, instead of talking about these raw scores, 10, 11, 12, whatever, I'm going to convert these into z values, or standard deviation values. So I want to say, okay, 10, what's that z-score? How many standard deviations below the mean is that? And so we do that calculation. 10 minus 15 is -5 divided by 4, -1.25. That'll tell us that we're 1.25 standard deviations below the mean. That's our z-score for that. 26 minus 15 over 4 is 11 over 4. Divide that, you get 2.75, or 2.75 standard deviations above the mean. So we're going to change this probability and ask it in a different way. Instead of asking for what's the probability we're between 10 and 26, those raw values, we're going to say, what's the probability you're between -1.25 standard deviations below the mean and positive 2.75 standard deviations above the mean. That's what we're going to figure out using those tables. So here's that same thing. If I want to figure this out, what I want to do is say, remember, those charts always go from a certain spot down. That's how those charts read. So I'll say, okay, well, what probability is it from 2.75 down? And it's, you can kind of see where that is at 2.75. We go down from there, and I'm going to take off everything below a -1.25, because we don't want that part. We just want in the middle area. So we're going to subtract that part off. And so if we look on our tables, we again cross-reference. Remember how we did that? Cross-reference those. We find on the second table, you find for 2.75 that you get 0.9970. On the first table, below -1.25, we want to take off that 0.1056, and this gives us a probability value of 0.8914. So the probability of falling in that area is 0.8914. And again, that just refers to, we can convert that back to the probability. We would be between 10 and 26 if we had a mean of 15 and a standard deviation of 4. So that corresponds directly to that. Okay, so we're converting our raw scores into standard deviations, or z-scores, and then finding the probabilities based on that. Now, that can be a little tricky at times, like on this one, where you notice our mean is 3. We're looking for a bigger than 2.3. Those are all really small values. They're all really close to those z-scores. And so sometimes it's easy to kind of get ahead of yourself and say, oh, I got 2.3 on my chart. I'm going to go straight to the chart. No, this has not been converted yet. Notice this is an X here, not a Z. We have to convert it to Z's first. So we're going to convert that 2.3 into a Z value, and we're going to really ask ourselves, what's the probability that we get a Z value of greater than or equal to negative 2.8? Now, again, the problem with that is that your tables aren't set up to do it that way. Your tables are set up to go from a certain spot down, not a certain spot up. And what we can do is use the symmetry, right? This is what we want to find. We can use the symmetry to say, oh, well, let me just do the mirror image of that. The mirror image of that would be not looking for what's above negative 2.8, but what's below positive 2.8. And I can flip that around. That I can use my table for. So I'd look at the second table, cross-reference 2.8, and I would get the value, 0.9974. So sometimes you got to do a little flip-flop, but the big thing I want to do on this example is just kind of warn you, caution you that when you have these small values, be careful, because if you're talking about X's, you need to do this conversion into a Z value, into the number of standard deviations. If you don't do that, you're going to be looking at the wrong number, and you're going to get the wrong answer. So very careful, caution you, watch out for that. All right, so let me let you work on 5, 9, 13, and 25. Pause the video, go do those problems, and then come back. Okay, so assume you've done those problems, so we're going to move on to the next part of this assignment. Find a value of z given a percent. So this is kind of going to work backwards of what we were just doing. We found the z value, and then we use the z value to find the percents. Now we're going to be given the percent, we're going to try to find the z value. So find a z such that 5.2% of the standard curve is to the right of the z value. Again, those tables don't work for going right, they work for going left. So what we're going to do is we're going to go, what's to the left of there? If they want me to say 5.2 to the right, what's to the left? Well, it's going to be 100 minus 5.2, or 94.8 to the left of that value. And so again, that table is based on probabilities. So you got to convert it into a decimal, so 0.9480. And we're going to find where on that second chart is the closest to 0.9480. Now, if you kind of fall between two values, a lot of times what you'll do is take like a half of it, half between those two values. But we're just going to round to the nearest z value at this point. But if you fall like right in the middle, you should take a half of those two. So, and I don't have my tables with me, but here I can look at this. All right, so 9.9480, we look at that table, and you're looking in the middle area for that percent. 0.9480, so I got a 0.9482 at 1.74. Wait, sorry, that was a 95, not a 94. So yeah, 1.9484, I got that, 0.9484, that looks like the closest, and that is at 1.63. So there we go, 1.63. Careful you don't mix your numbers up like I did there. Okay, find the value such that 80% of the standard normal curve, and let me say, you might want to, when you're doing this, is kind of draw yourself pictures, just to kind of keep track of what you're talking about. So this is asking for what's Z if this area was 5.2%. And that's where we got the 94.8%. So it sometimes is helpful to kind of draw yourself a picture to kind of understand what's going on with the problem. Find the Z value such that 80% of the standard normal curve lies between negative Z and positive Z. So we're looking for this. We're looking for a Z value so that positive and negative is 80%. Unfortunately, that is not one of the empirical values. If it was, I would make that easy, but it's not. We go from like 68% to 95%. So we jump over 80. So what we're going to do is we're going to kind of look at this and we're going to say, okay, if there's 80% in the middle, that means there's 20% outside of the middle, which means 10% up, 10% down. If we add that the 10% down, because remember, that's how the chart works. It works from that spot down. If you take from that spot down, that would give us 90% or 0.90 of that spot. And looking at the second chart, you can cross-reference that and get that 1.28. So 0.90, 1.28, yep. So it's 0.8997. That's pretty close to 90. So there you go. You can't look for 80% in here. You got to look again. The chart goes from a certain spot all the way down. So you got to kind of add that extra 10% on there to figure it out. Okay, let me let you do 15, 19, and 23. Pause the video and then come back. Okay, I assume you have done those problems, and let's go on to the next part. So this next part deals with checking for normality. Does the data we're looking at, do we think it comes from a normal distribution? Not the standard normal distribution, just any normal distribution. And so we're going to look at 4 ways of looking at this, and oftentimes you want to look at more than one way. You don't want to just depend on one type of result and say, okay, well that's it. That's all there is. You want to look at several of these, probably all 4 if possible, to figure it out. So these are the 4 things. One thing you can do is you can make a histogram. So you can make yourself a probability relative frequency table, and then make yourself a histogram and see, does it look mound shaped? Does it look bell shaped? Now, because it's a histogram, it's going to be a bunch of bars there that are touching. Remember, histograms have to touch. Histograms are made out of bars, but they're not bar charts. Don't confuse them. But since it's bars, it's not going to be an exact smooth curve. But you want to say, oh, well, it looks like that bell shape, like that shape I would expect. And that's because you're only maybe looking at a set of data or something. You're not looking at the entire population all at one time. So you have that histogram, and you're saying, oh, does it look bell shaped? Versus, if I had something that was bimodal, kind of look like that, I would say, oh, well, no, that doesn't look like a normal distribution curve there. You should have no more than one outlier. And the way we're going to calculate outliers is back how we did the box and whisker plots and the 5 number summary to do that 1.5 times the interquartile range of that. So we're gonna do it the same way, and we should have no more than one. No more than one. If you get more than one, that might mean it's not quite in that normal distribution thing. Maybe it's more skewed. If you got a bunch of data down here, and then you got this one value like way over here, that can give it a kind of skewed. It's not really normal there. Now, so that's now if it's really close, I mean, this is just a rough estimate of what might be an outlier. All right, the next thing we're going to do is calculate the Pearson's index. And this should fall between -1 and 1. And the formula for that is this: 3 times the difference between the mean and the median all over the standard deviation, okay? Now, the idea here is when you start getting skewed, then you're like in this picture, my mode is the highest value, right? That's the one that happens most often. And then my median and my mean are going to start getting kind of stripped off to the side. So I think the next one would be median, and then after that would be the mean, right? This outlier is kind of throwing my mean off. And the question is this difference times 3 going to be bigger than the standard deviation? If it is, if those difference between those two is so big that it's beyond that, if I multiply it by 3, it's bigger than the standard deviation, then that's going to be an indication that we're not normal enough. We're not really normal. And then the last one has to deal with what's called a normal quantile plot. And that should come out to be approximately linear. And we'll talk about how to do that. There are programs that can do it, but we're going to do it by hand here, just to kind of show you how to do it. All right, so let's look at this data here. And we're going to go through each of those ways of checking something. So remember, histogram, check for outliers, this Pearson's index value, and then this graph, and see if it comes out to be approximately linear. So here I have a table. I've already got a bunch of stuff calculated. You're going to do a problem. They're going to have that stuff already calculated for you. Just kind of look. They have like a data block, and you got to kind of like, oh, that's those. So like it has a 5-number summary. This is the minimum. This is the first quartile, right? The 25% percentile mark. This is the second quartile, or the median. This is the third quartile, the 75%. And then this is the maximum value. Remember, that's what that 5-number summary tells you. And so what I'm going to do on the first one, I'm going to check to make this a histogram, right? So I'm going to use the frequencies to do that. I'm going to use the other 2 columns for some of the later things I'm going to do, but I'm going to use the histogram. So on this axis, I'm going to have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And then on this other axis, we're going to go, 1, 2, 3, 4. It looks like we go to a high of 6. So 6. Let's see, that's 3, 4, 5, 2, and 1. All right. So for 2, remember, when you make this histogram, the bars have to touch, and they should be, the number should be at the midpoint. So that bar looks like that. 3 is 2. Should be a 3, right? 3 is 2. 4 is 3. 5 is 4. 6 is 5. 7 is 6. And then it looks like it just goes back the other way. So 8 is 5. 9 is 4. Oh, no. There we go. All right, sorry. 9 is 4. 10 is 3. 11 is 2. And 12 is 1. Okay, so does it look mound shaped? Yeah, yes. So for my first test, I would say looks mound shape. Okay, so I think it looks kind of normal under that. So let's continue on. So the second thing I can check is check for outliers. So first thing I need to do is find out what's the interquartile range. And remember, that was Q3 minus Q1. So 9 minus 5 is 4. and then I take 1.5 times the interquartile range. So 1.5 times 4, so 6. And my extreme values are going to be, so on the lower end, lower edge, I'll just say edge, that's going to be 5 minus 6, so -1. So if I get any values below -1, we're going to call that an outlier. And well, our lowest value is 2, so we don't have to worry about that. And our upper edge is going to be 9 plus 6, right? So we're using these interquartile, or sorry, the Q1 and the Q3, the 25th percentile and the 75th percentiles, and we're adding that 1.5 times a quartile range to check for those edges of the outliers. And again, 15 is the upper end, our highest value is 12, we're good. So this has no outliers, no outliers. Okay, that's great. All right, then the third thing to check for is that Pearson's index. And so remember the Pearson's index, that is, let me get the formula, 3 times the mean minus the median, or Q2, if you want to say, that's Q2, second quartile, over the standard deviation. So I know I kind of mixed this up to sample where these are population values instead of sample statistics. We're just going to go with it. So I kind of mix the two in here. So I'm gonna put mu here, just mu. Okay. 3. Okay, so our mean is 7 minus 7 is our sample, or our Q2, our median, over our standard deviation, which is 2.4. Well, 7 minus 7 is 0. 0 times anything is 0. So that's going to be 0. That's between 1 and -1. So I'll say it passes the Pearson's index value test here. It fell between -1 and 1. 0 falls in that. All right, and then the fourth one is going to be making a graph. So this is how you make the graph. So that's why now I'm going to use these last two columns. So I'm going to calculate the cumulative frequency. And so again, how you calculate the frequency is you add up all your frequency, or sorry, your relative frequency, cumulative relative frequency. How to calculate the relative frequency is you add up all your frequency and then you divide by your frequency by the total, right? And that's how you get those. So this comes out to be 0.03. And then you add those up as you come to each value. That's how you calculate that. And again, we did that long time ago, chapter, I want to say chapter 2, we did that in. But the big thing is we're going to calculate the Z value for each of these. This is what we're going to do. We're going to calculate the Z value for each of these cumulative frequencies. So remember, the Z table, it goes from a certain spot down, right? That's how that Z value, well, that's what we're doing here is we're saying from there down, we have a certain relative frequency or a certain probability of getting that value or lower. So what we do is we go to our Z chart and we start cross-referencing, you know, what Z value is it for 0.03? What Z value is it for 0.08? What Z value is it for 0.17? So for 0.03, that looks like it would be negative 2.75. Negative 2.75. Wait, is that right? Am I looking at that right? No, I'm off by a power of 10. Okay. For 0.03, there's a 0.0301, negative 1.88. Negative 1.88. Okay, that seems more accurate. It's off by a place value. Okay, so what I'm gonna do is I'm just gonna go through and I'm gonna find those values for Z. So, and again, the cumulative relative frequency, you're adding up every probability on there. So let's see, 6.42, negative 0.20. This is going to be positive 0.20. And it's going to, looks like it's pretty much symmetric here. So all right, and 12 would be 100%. We're not going to put that on there. So you leave that there. I'm going to make myself a graph here. And on this axis, I'm going to have the Z values. And on the y-axis, I'm going to have the raw scores, right? So we're going to go up to 12. So that's 6, 9, 3. And then we're going to have a Z value of 0 and -1, -2, -3, 1, 2, 3. Okay. And what this should form is a line. So let's see if that works. So a Z value of -0.88, somewhere around there, has a raw score of 2. Okay. A Z value of 1.4, so say somewhere around there, has a raw score of 3. A Z value of 0.95, that's just under 1, has a raw score of 4. The Z value of -0.58 has a raw value of 5. -0.2, 0.2, about a fifth of the way, has a raw value of 6. Positive 0.2 has a raw value of 7. Positive 0.5, a little bit more than half, has a raw value of 8. Where am I at? Right here, 0.95, raw value of 9. So around there. Raw value 1.4. It's a little bit less than 1.5, has a raw value of 10. 1.88. So raw value of 11. Okay. And so the question is, does that look linear? Does that look like you might be able to use a line to kind of simulate that data? And yeah, it looks pretty linear. You know, what would it look like if it wasn't linear? Well, it might look, you know, something like that, or it might look something like that. You know, some kind of curvy type shape to it. Those would not be linear. Those would tell me, or, you know, maybe it like goes like that or something. I mean, I guess it wouldn't go back down, but, you know, if it kind of did something like that, then, you know, a little bit more curvy, that would be a problem. And we're not getting that. We're getting pretty much the straight line here. So that looks pretty good. That looks like it passes. So if I were to say, you know, does it look like this data we're drawing comes from a normal distribution? I would say based on these 4 tests, yeah, it does. It does look like it comes from a normal distribution. Now, you don't want to depend on any one test. Like I said, one test might give you like, I'm not sure if it's normal, but it looks normal from the rest. So you kind of have to use more than one test to kind of come to that conclusion if you think it is normal. All right. So the rest of the assignment, section 6.3, do problems 1 through 4, do all of those, and that's the rest of the assignment. All right, take care, and I will talk to you later.